Exactly what lies beyond the edge of our observable universe is so far uncertain, and as we've said already, it may be infinite. In fact, none of the current mainstream cosmological models of the universe allow for a physical limit to the universe's size. Even the models which do say our universe is finite claim it is 250 times larger than what we can observe, at least. And the theory of cosmic inflation says that a finite universe could be as much as 100 sextillion times larger. That's pretty big. But what do we mean when we call something big? Is it large in terms of length, volume, time, space? Let's take a simple physical object to start with, a piece of paper. Do we measure it across in one dimension? Sure. Oh look, this piece of paper is 20 centimeters long. Good for you. But what about a banana? If you measure that across one dimension, it doesn't really give you a true account of its size. So instead, we might measure its height, its width, its circumference, and then try to calculate its mass. However, what if the thing you're trying to measure extends beyond 3 dimensions? What if this object doesn't play by the rules you're used to? How do you even find the edge of something when you've no idea what it is? This is the problem we have when we try to comprehend the size of the universe. There are many different theories regarding its shape of, or if it even has one. Some believe our universe could be spherical, others say it is flat or curved, but perhaps more important is the question of whether it is finite or infinite. One theory claims that the universe is torus-shaped, and as with everything that seems to happen these days, this style of universe was predicted several years ago in an episode of The Simpsons. Much like Homer describes, this universe is donut-shaped, and because of this, it has one very strange property. In this universe, you can travel infinitely in any one direction, but eventually you'll end up back in the same spot you started. This offers you a bizarre clash of finite and infinite dimensions, so how could you possibly ever measure a space like that? But you can't. And you can never reach the edge, because there isn't one, even if there is a limit to the amount of matter in there. There are 2 more intriguing theories on this subject, and these both involve a different kind of infinity. One which states that the universe goes on forever, and another which claims that parallel universes exist alongside our own. Both of these concepts are hard for humans to imagine, as if something truly is infinite. Then every possible event from every moment of time in the history of the universe can, will, has, and is currently being played out somewhere in the universe an infinite number of times. If the universe is infinitely long in all directions, all you need to do is travel far enough, and eventually you'll find an Earth replica full of cats, or a place where all the stars of the night sky line up to spell, "Send nudes." But once again, there can be no edge to this universe. And if parallel universes exist, as in the theory of the multiverse, then the same is true. But you'd have to somehow travel between these universes to see such things. So, if time is considered the 4th dimension, would the path to the multiverse be the 5th? Or would our universe's edge be defined as the barrier between our universe and those parallel to it? And if there are such things as parallel universes, is that it? Or do more universes exist on even further dimensions which we cannot comprehend? Are we humans as limited in our vision and thinking as someone without depth perception who can only see in 2D? Will we one day realize that the universe is far more infinite than we could ever imagine? The idea of something being more infinite than infinite sounds counterintuitive, but this depends on where you apply the word. For example, the universe might be infinitely big in terms of size, and it also may be infinitely big in terms of how many parallel universes exist. These 2 ideas are not the same, because it's like saying I have one infinitely sized watermelon and I have an infinite amount of watermelons. The idea of infinity means something different in each case. I mean, we could have an infinite amount of infinitely sized watermelons, Infinity times infinity sounds like a lot. So, how do we find the edge of that?